On your notes, you're going to label 11.1, circumference and arc length. Bless you. So here's what you got going on today. This exact definition. La la. Boom. The circumference of a circle is the distance around the circle. That was perfect. Consider a regular polygon inscribed in a circle. What does inscribed mean? What does it sound like? Inside. So think about this. I'm going to pop up one. Here's a quadrilateral. It looks like a square. Is inscribed in a circle. As the number of sides increase, so 4 sides, 8 sides, I didn't count how many sides, what does it look like is happening to the polygon? It's getting rounder and rounder. We've already looked at it in this class, I'm pretty sure. Does anybody remember how many sides of a polygon looks exactly like a circle?
99.
It's close.
96.
96, good. If you Googled a 96-sided polygon, it literally starts looking like a circle. All right, so whenever it comes to a circle, if you're in Algebra 2, you've already approximated pi, and I described it here. It's the ratio, so the fraction, of the perimeter of the polygon, which is called a circumference, to the diameter. All right, so if you took any circular object and you found the circumference and divided it by the diameter, you would get 3.14159253, so on and so forth. Okay? So, we're going to talk about the 2 formulas you need for circumference and when to use them. Students really struggled this morning with figuring out when to use which formula. Okay, so the first one is in the bottom left. You have learned this before. C equals pi times d. What does the letter d there represent? Nope. Diameter. So guess what? You use this formula when you have the diameter. If you do not have the diameter, you don't use this formula. Alright, so that's the first formula you hopefully are a little bit familiar with.
Can we write, like, when to use it?
You can write what it's for. Circumference. Equals. Alright, so what is the relationship between the circumference and the diameter? Think about a circle. Sorry. What's the relationship between a diameter and a radius? Sorry, wrong one.
Radius is heavy.
The radius is half the diameter, and the diameter is double the radius. It says it right here in the next sentence. Because the diameter is 2 times the radius, the second formula is written here. C equals, you can ignore the middle, it's just kind of the word, 2 pi r. So it's the second formula. It's also written here. 1, 2. So these are the 2 formulas you'll use for circumference. That's how you find the measure all the way around a circle. All right, so one thing to note, you'll want to write this on your notes. If a problem says answer an exact value, you're going to leave it in form with pi. I'll explain what that means. These are your 2 examples, 6 pi or pi over 2. So if it says give the exact value, because it will, you need to leave it in terms of pi. On your notes. So, an example, let's say you were trying to find the circumference. Wow, my finger is not there. Given a diameter, pick a number between 1 and 20.
30. 19.
Sure, of 19. All right. Find the circumference given, the diameter of 19. If it said leave an exact form, sorry, I started writing yellow. Circumference equals, if you're given the diameter, should you use the first formula or the second formula? The first one, because you're given the diameter. So what is the diameter here, 19? So most people would put 19 pi, and they would be correct. This is the exact form. If I didn't ask for exact form, you would hit S to D, and it would come out with a decimal. All right. Speaking of that, go ahead on your calculators and look at the, I don't even have one to show you. At the bottom, you will never use 3.14. You will use the exact value of pi. All the way in the bottom row in the middle, you'll see in the yellow there's a pi button. You're going to hit shift and pi, and it should pop up. If it does not, then your light is not. Okay? Yeah, where it says x times 10 to the x. Sit down. So whenever you use pi in these scenarios, you're going to use that pi button. Okay, don't put in 3.14 or your answer is going to be off. All right, so we're going to do 2 problems that are written right here. Letter A, you want to write these on your notes. Find the circumference of a circle with a radius of 9 centimeters. So these are for your notes. Helps if you write, yep. A circumference of a circle with a radius of 9 centimeters. So if you look, you can already see that we've used C equals 2 pi r. Why did we use this formula instead of pi times d? Because we're given the radius, right? So because we're given the radius, we can use this formula. Says circumference of a circle with a radius of 9 centimeters. So we're going to plug in 9. Where are we going to plug in 9?
For the R.
For r, for the radius. Okay? Whenever you plug them in, when a number is next to pi, that's multiplication, just so you know. So you're going to do 2 times pi times 9. Does it matter what order you multiply in? No, it does not. 1 times 2 is 2. 2 times 1 is still 2. So, what is 2 times 9? 18. So this is technically the same as 18 pi. Now I want you to look at this. If it said leave an exact value, you would leave it like pi. Okay? But it doesn't say that in the directions. So you're going to hit S to D and round to the nearest hundredth. What do we get?
56.
You get what?
Oh, 56.
Yeah, 56.55. So the circumference is about 56.55 centimeters. All right, letter B. We're going to find the indicated measure, which is the radius of a circle with a circumference of 26 meters. So we use C equals 2 pi r again because we're looking for the radius. Okay? So where am I going to plug in 26? For C, because it is the circumference. All right, so here is where a lot of students struggle. If it just said 26 equals 2r, what would you normally do? Divide by 2. You're going to do the same exact thing here. Pi represents a number, right? So just think of it as another number. You're going to divide both sides by 2 pi. I know it looks weird, but that's how you solve for r. Type it in your calculator. It will reduce it to 13 over pi. And then hit S to D and round to the nearest hundredth.
Wait, is this right?
Yep.
Okay.
So you should get about 4.14. Good. Okay. Go ahead and open up your student journal to page 318. Which formula are we going to use? C equals
Pi d.
pi times d. Reason being, we're looking for the diameter. We're not looking for the radius. All right, we're given a circumference of 10 inches. So where is 10 going to be plugged in?
C.
For C. So 10 equals pi times d. So how do I solve for the diameter? Divide by what? Pi. All right, so d equals 3 point... Well, yeah, round to the nearest hundredth, 0.18. Questions about number 1? All right, number 2, circumference of a circle with a radius of 3 centimeters. Which formula are we going to use here?
Pi r.
Yep, 2 pi r. And where am I going to plug in 3? For r. So 2 times pi times 3. Plug that in your calculator, hit S to D. What is it, 18.85 centimeters. Questions about either problem?
This is better. So you doing? You just take the. You just take
I plugged it into the formula and then I ended up dividing it. So don't think of it as like a ritual of I just multiply it every time or divide it by pi every time. Just plug it in the formula and then go from there. Does that make sense? Yes, no, maybe so.
Yeah, like, what do you mean, dude? Oh, okay.
Like I used pi times d because it's the diameter, or looking for the diameter. Then I knew the circumference was 10, so I plugged in 10 for c. Whereas here I was given the radius, so I plugged in 3 for the radius. All right, just going to pop up the answers. This is the second, so this is a new formula. You have never seen this before, probably in your life. If you have, congratulations. If you have not, welcome to the club. Using arc length to find measures. Okay, so think about this. All right? A circumference is the distance around a circle, right? An arc length is a portion of it. So it would be like the crust of your piece of pizza out of the entire pizza. So arc length is a portion of the circumference of a circle. You can measure, you can use the measure of the arc in degrees to find its length in linear units. So up until now, you have learned about arc measure in degrees. Okay, if the central angle was 40 degrees, that meant the arc measure was 40 degrees. But is that like a length? Could you measure that with a string or with some sort of tool in inches or whatever? Not the way that it looks right now, but there is a measurement for it. Okay, so you're going to learn how to do that. The formula for it is in a circle, the ratio. What is a ratio? A fraction. Tyler, pick your head up. Jerome, pick your head up. Sit up. Tyler, sit up. A ratio is what? A fraction. It's going to be a fraction of the length of the given arc. So like 5 inches, 27 feet, something like that. Over the circumference. So a piece of the circumference over the entire measure of the circumference. And it is equal to the ratio, so another fraction, of the measure of the arc, so like 40 degrees, over 360. So I wrote it right here on the wall. It's also officially in your book. But what I did differently than your book is it's the arc length. And instead of writing 2 pi r, because you're not always going to use 2 pi r, what does 2 pi r equal? The circumference. So instead of the formula, I would prefer you just know that that's the circumference because it's a piece of the circumference over the entire circumference. A piece of the 360 over the total 360. All right? So I'll give you a minute to write this one down. You are going to need to know when to use this. And you use this to find an arc length. You can also use it to find the circumference given the arc length. So what I also want to point out to you, what I wrote on this dry erase board to the right of my board, is that this first fraction is in length, meaning inches, miles, feet, centimeters. Okay, the second fraction is going to be in degrees. All right, so it's going to be an arc measure in degrees over 360 degrees. If you have them mixed up, so if you have inches over degrees, then you have something wrong. Okay, so length over length, degrees over degrees. So we're going to do some problems. We just talked about these. All right, so you guys do these 3, or write these 3 on your notes. Draw them. You don't have to solve them yet. All right, so on the first problem, I've already written the formula. What are we looking for in letter A? What does it say to find? The arc length. So, when we're filling in the formula, do you know the arc length? No, that's what we're finding. So you can write X, you can write A for arc length, you can write L for arc length. I don't care. Do we know the circumference right off the bat? No. Could we find the circumference? How can you find the circumference?
Multiply 8 by 2 and 9.
So you see how you have 8? You have the right idea. 8, what do we call that? The radius. So you can plug it in the formula. C equals, so would we use pi times d or 2 pi r? 2 pi r. You did it in your head, Brandon, so that's fine. So C equals 2 times pi times our radius, which is 8. So here's what I want to tell you. You need the exact value. You will not hit S to D in the middle of the problem. So what you are going to do is you're going to write it in terms of pi. Again, does it matter what order you multiply in? No. So you're going to do 2 times 8. What is 2 times 8? 16. So this is the same thing as 16 pi. So the circumference of this circle is 16 pi. Is everyone okay with how we found the circumference?
Couldn't you do it,
You can-
multiply 8 times 2 and then 7 is the diameter?
Yeah, it's the same thing. That's why I said you did it in your head. 8 times 2 is 16. You just got to this without doing this part. All right, now we're going to use the measure of the arc. Remember that this whole second fraction is going to be in degrees. So what is the measure of arc AB? Not in length, but in degrees. It's going to be 60 degrees. And then over 360. It will always be over 360. So here's what we're going to do. This is called a proportion. It's one fraction set equal to another. What have we been doing to solve a proportion? Cross multiplying. You can do cross multiplication, but here you can also do one other thing, which would save you a step. What's happening to x?
We multiply by 3
It's being divided, right? By 16 pi. So what's the opposite of dividing by 16 pi? Multiplying both sides by 16 pi. So you can cross multiply if you want, but this is literally the same thing. So what you're going to type in your calculator, you need this fraction, 60 over 360, multiply times 16 pi. Write the answer on your paper. You do not have to say it out loud. I just want to make sure everyone can put this in their calculator. That's the correct answer. What'd you get as your answer? Do you have a calculator? Did you type it in? So you're going to hit S to D now. At the final answer, you're going to have it in the decimal form. That is correct. So you should have 8.38, and we are in centimeters. All right, so all that I did was plug into the formula, and then I used algebra. If you're not good with proportions, you need to get good at it. No questions, we can move on. All right, I'm going to make that super small so that we can do the next problem. What are we solving for in the next? The circumference. So we're going to use the same formula. All right, what is the arc length of x, y? 4.19. Do we know the circumference? Do we even know the radius? No, we don't know the diameter either. So I would write C. You can write X. You can write whatever you want, but that's what we're solving for. All right, what's the measure of that arc XY? This one's going to be in degrees. 40 over 360. So here is different because C is on the bottom, the missing variable is on the bottom, whereas over here the missing variable is on the top. So what you can do is solve like you would solve a normal proportion, and you can cross multiply. C times 40 is 40C. What is 4.19 times 360? 1508 point, I know it's a decimal, 4. Alright, then we divide by 40. And what does C equal? 37 point what? 71. Alright, so here's what I'm going to give you an extra, because you're going to have a problem like this on your homework, also on your quiz. It would say find the radius. So how could you find the radius if you were given the circumference? Plug it in the formula. Which formula would you use?
C 2 squared R, or not squared.
2 pi r. Alright, and what is our C? C is 37.71 equals 2 pi r. How would we solve for the radius from here? Divide by what? 2 pi. Alright, so then what would the radius be in this problem? You'll have to type it in because I don't memorize it. It's 6. Alright, so you will have a problem just like that. It'll say find the radius. Whenever you have to find the radius, you need to find the circumference first, and then solve for the radius afterwards. Any questions on this problem? You're good?
So, you made up that second part?
Yeah, no, I took this number. I just said if it ever asks you to find the radius. I made that part up, but the number came from this problem. All right, letter C, what are we solving for? An arc, nope, an arc measure. So whenever you see the M right here, that means measure. That's going to go in the right fraction. Whenever you see arc length, that goes in the left fraction. All right, so what is the arc length here? Where's the only length? I mean, I see 2 lengths. 15.28 is not this length. What is 15.28? The radius. So it's not the one we're looking for. 44 is the length from R to S. So 44 is what we're going to use. Do we know the circumference? Can we find the circumference? Yes, how can we find the circumference?
2 pi r.
Yeah, 2 pi r. All right, what is our radius?
15.28.
Yep, 2 pi times 15.28. So you're going to write it in terms of pi, so that would be 30.56 pi. All I did was multiply 2 times 15.28. Questions about circumference? Okay. So we plug it in the bottom. So it's 30.56 pi. All right, and it equals, do we know the measure of the arc in degrees? We don't. So you can write whatever you want. You can write x. All right, and then we write over 360. It doesn't matter if you don't know the top of the fraction. The bottom will always be 360. So now what is happening to what's missing, the missing x? It's being divided by 360. So what's the opposite of dividing by 360? Multiplying by 360. So multiply both sides by 360. Yep, that's correct. So you should get 164, right? 0.99 degrees. Any questions on any of these three problems? These are the only I'm doing with you. Okay. Here we move on. So these are two new formulas. This is the last slide of our lesson. Something you call radian mode. If you were to go to all of the modes of your calculator, R stands for radian. When you get to trigonometry and in Algebra 2, you're going to use radians. Okay? So degrees, I want to show you the difference. Degrees, you've always had a number written and then a degree symbol. Whereas radians, I'll write on my iPad. Radians, you'll have every answer with a pi in the answer. That is something new to you. So radians, everything is in terms of pi. It's like a whole other world. So there's a way to convert back and forth from degrees to radians. Okay, so to go from degrees to radians, you're going to multiply. So this is a formula. You're going to multiply times pi over 180. So you're going to take whatever number, like in letter A, we're going from 45 degrees into radians. All right, so our example, convert 45 degrees to radians. So you're going to take 45 and you're going to multiply it by pi over 180. Multiply it straight across, you get 45 pi over 180. And then you need to reduce. I don't know if your calculator will reduce it correctly, but you can also just type in 45 divided by 180. They're both divisible by 45. So it should be pi over 4. Am I right? 80 and 20. That's your answer. That is our radians answer. So you don't write 1 pi, just like you don't write 1x. You just write pi and then over 4. Okay, so that's converting from degrees to radians. Converting from radians to degrees, you're going to multiply by the reciprocal. So you're going to multiply by 180 over pi. Do you remember this from last year, Andrew? So you're going to multiply by the reciprocal. The pi being on the bottom, when you multiply, the pi is going to cancel out. And our example is 3 pi over 2. So we're going to multiply 3 pi over 2 by 180 over pi. I suggest that you do cross cancel. It makes your life easier. Pi's cancel out. Can 2 go into 180? Yes, how many times? 90. And then you multiply straight across. 3 times 90 is 270. And there's nothing on the bottom, so it's just 270. All right, so from here you're going to take out your textbook and the paper you did your bell ringer on.